how many of the first 1,000 positive integers are multiples of neither 6 nor 9. Let's start with these three words, the first 1,000 positive integers. What are those? Well, the first 1,000 positive integers are the numbers 1, 2, 3, all the way up to 1,000. And what we would like to know is, of those first 1,000 positive integers, we want to know how many are not multiples of 6 and not multiples of 9. If you want an example of a number which is not a multiple of 6 and not a multiple of 9, 5 is one such example. It's not a multiple of 6 or 9. Another one is 13. 13 is not a multiple of 6 and 9. You can imagine there's quite a few of these. Well, one way to solve this problem is to list them out, but that's just going to take too long. So there's got to be a better way. I'm going to start out here by listing out the multiples of 6 in the first 1,000 positive integers. So here they are. The first one is 6, and then there is 12, and 18, and 24, and 30, etc. In fact, what's the last one? If you keep this process going, 1,000 is not evenly divisible by 6. Turns out that the last one will be 996 is the last integer that is a multiple of 6. Now the next question is, how many of these are there? Well, if you take 996 and you divide it by 6, that will give you 166 numbers in that list. So there's 166 numbers that are multiples of 6 in the first 1,000 positive integers. Let's do that same thing on multiples of 9. List them out. There is 9, 18, 27, 36. What's the last one? You can probably imagine what this is. It's not 1,000, it's 999. So the next question might be, how many of those numbers out there are multiples of 9? And the way you answer that is pretty much analogous to answering the previous number of multiples of 6. We simply take 999, which is the last one in the list, divide that by 9, and there are 111 multiples of 9 in the first 1,000 positive integers. Now, it seems like we have the problem solved here. All we have to do is take 1,000 and subtract out 166 and subtract out 111, and those are the ones that are not multiples of 6 and 9, but there's a wrinkle. And the wrinkle is we've double counted some of these numbers. Do you see the 18 that shows up there and there? It got double counted. And in fact, so did 36. 36 will show up in this list. It'll also show up in this list. So somehow we've got to eliminate those that are double counted. And in fact, those that are double counted are multiples of 18. And the multiples of 18 look like this. 18 is a number that shows up in both lists. 2 times 18 is 36, and 36 shows up in both lists. 4 times 18 is 54, and on it goes. And the last multiple of 18 that shows up is 990. Notice that 990 will be the second to last number in this list, and it also happens to be the second to last number in this list. This is the last one that shows up in both of these lists. Next question, just like we've asked before, is how many multiples of 18 are there in the first 1,000 positive integers? And if you take your 990 and you divide it by 18, you will get a total of 55 numbers in that list. Now at this point, it's worth creating a Venn diagram, and I'll draw that Venn diagram down below here. And in that Venn diagram, I'm going to put two sets in here. This is the set A. This will be the set B. And A in this Venn diagram will be all of the multiples of 6. So in this circle right here would go all of these numbers, 6, 12, 18, etc. And the set B here will be multiples of 9. So in this set right here, you will get 9, 18, 27, etc. Now, if you look at A intersect B, and that is the area in common with both of them, that's the area right here, those happen to be the multiples of both 6 and 9, and those are the multiples of 18 here. So all of these numbers wind up in the middle section. Notice that there are 55 numbers in that list, so I'm going to go ahead and label that as 55. Furthermore, if you want to know how many go over here in this section, those are multiples of 6 that are not multiples of 18. So for example, 6 and 12 would go over there. All we have to do is make sure that this number 55, the number in this intersection, plus the number that show up over here, add to 166. And so this turns out to be 111. And likewise, if you come over to the number that will show up over here, that are not in A intersect B, but they're in here, that's going to be 111, which is the total number for all of B, minus 55, and that will leave you with 56. So finally, to see what we have, you've got 55 that are multiples of 18. You've got 111 that are multiples of 6 that are not multiples of 18. And you've got 56 that are multiples of 9, which are not multiples of 18. So those three numbers there, in fact, if we add them up, and let's do that over here on the side, 55 plus 56 plus 111, when you add those, you get 222. So what we have is, we know the sum of these three numbers here is 222. The other numbers that are out there amongst the 1,000 are those that are not multiples of 6 and 9. And so if you take 1,000 minus 222, you will get 778. And that number right there turns out to be the answer to the problem. So the original problem was how many of the first 1,000 integers are multiples of neither 6 nor 9. The answer to that question is 778 using the Venn diagram.